today we will present about two tasks that are given by Dr. Suzila, which is task 1 is a growth populations, while task 2?
Task 2 is about replacing roots. It's based on the question given from Dr. Suzila.
Let's go! Population growth refers to the increase in the number of people living in a particular area over time. There are several factors that give big impact on population growth, such as birth rate, death rate, and migrations. In the task, we mainly focus on the application of first-order differential equation, the total population in Singapore, in the 2000 to 2020. In 1798, Thomas Malthus, an English scholar and economist, developed a fundamental concept for modeling and analyzing the human population. The implementations of the Malthusian model used in task 1 is to find the growth of population in Singapore. The Malthusian model assumes that the rate at which total population in Singapore increase at a given time is proportional to the number of population at that time. The Malthusian model can be written as dP over dt equals to kt, where pt is the number of population in Singapore at times and k is a constant of proportionality.
For the table, we can see the population growth in Singapore from 2000 until 2018 is rapidly increased due to economic growth, and immigration came to Singapore made the fertility rate increase. While 2019, the data show 5,006,069 and 563, and in 2020, 5,006,020 and 150, the population is decreased due to pandemic COVID-19, where the border was closed, and also another reason, the people died because of COVID-19 disease. We conducted a graph that showing data in the population data in Singapore that from 2000 until 2018 is rapidly increased until 2019 and 2020 is decreased due to the reason that we stated before. For particular solution, we also conducted a graph that show exponential growth.
To get particular solution equation, we use dP over dt equals to kp, and we rearrange the equation so that we get 1 over p dp equals to k dt. And then we integrate both sides so that we can get ln p equals to kt plus c. And also we exponent both sides so that we can get p equals to exponent kt exponent c. In here we get p equals to plus minus exponent c exponent kt. P equals to A exponent kt, where plus minus exponent c is equals to A. Using the initial condition t equals to 0, which is in 2000s, population equals to 4,035,245. We insert the in equation so that we get p equals to 4,035,245 exponent kt. We can find the value of the constant k by using t equals to 1, which is in 2001, where population is equals to 4,116,166 in the equation, so that we can get the constant proportionality is equals to 0.0199. In here we can insert k and a that we get into the particular solution equation, so we get pt equals to 4,035,245 exponent 0.0199t. To predict a future record of number of people in Singapore, we set t equals to 4, which is 2024, so that we get 4,369,581. From worldwide, the actual value of population in Singapore in 2024 is 5,832,387. Hence, the future number by particular solution of people in 2024 is 4,369,581. We observe that the estimate value is lower than the actual value. Next, to predict a past record of number of people in Singapore, we set a t equals to -4, which is 1996, where we get 3,726,491. From worldwide, the actual value of population in Singapore in 1996 is 3,664,491. 560 people. Hence, the future number by particular solution of people in 1996 is 3,726,491. We observe that the estimate value is higher than the actual value.
The reason why we calculate the percentage error because we want to know the difference between the theory value from a particular solution and the actual value from the data. From the previous slide, we already calculate the theory value by using a particular solution, and while for the actual value, we are using the real data for past and future. What we got 25.08% for future, different from what we predict in the theory value. For past, we get 1.69%, different what we predict in the theory value.
Question 6. The values calculated from the particular solution are not accurate with the actual values. In 1996, the value of population from the solution is higher than the actual value with 25.08% percentage error, whereas in 2024, the value is less than the actual population by 1.69%. The difference in the value of actual population and the value from the particular solution might be caused by a few factors affecting the number of population at the time. For example, the COVID-19 pandemic in 2020 caused thousands of deaths in Singapore and millions worldwide. Next, the population growth in the past might be affected by high birth rates. This is due to many societies having a high fertility following the cultural norms and lack of contraception. On the other hand, wars can significantly reduce populations due to casualties and displacements. Lastly, the population in the future might be affected by dropping fertility rates in many countries that may decline the population and a rise in the elderly population, leading to fewer working age people and lower birth rates. From the calculation by the Malthusian method, the total population value expected in Singapore for 2000 is around 3.7 million, which is higher than the actual population, while the expected value after 2020 is around 4.2 million, which is lower than the actual population. The expected total population from 2000 to 2020 is not exact as the recorded data due to factors that cause the actual value to be higher or lower than expected, such as the influx of foreign workers and birth rates decline, respectively.
Step 1, we divide this interval 1/5, 3/2 into n subintervals, which equal with h, where h equal to b minus a over n. And for 7 ordinates, 3/2 minus 1/5 over 7, and we got 13/17. While for 9 ordinates, 3/2 minus 1/5 divided by 9, and we got 13/19. For 7 ordinates, we got 8 interval start with 1/5 and followed by 27/17, and lastly 3/2. For fx, start with 1.875288 followed by 1.828399, and lastly 2.190560. And for coefficient, start with 1 followed by 2 and lastly end with 1. And for coefficient x multiply fx, we start with 1.875288 followed by 3.656798 and lastly 2.190560. And the total of coefficient x multiply fx, we got 28.126892. And for 7 ordinate, from the equation given, we total it and we got 2.611783. And for 9 ordinates, we got 10 interval consists of 1/5 followed by 31/90 and lastly 3/2. And for fx, we start with 1.875288 followed by 1.829329 and lastly 2.190569. And for coefficient, we start with 1 followed by 2 and lastly we end with 1. For coefficient x multiply fx, we start with 1.875288 followed by 3.646658 and lastly we end with 4.381138. And we total up coefficient x multiply fx, and we got 38.335996. And we put the total coefficient x multiply fx into the equation given by the question, and we got 2.768711.
Hi everyone, so I'm going to talk about the task 2 that we have been conduct the graph. We have two graphs, first for 7 ordinate and the second one is 9 ordinate. So the equation that have been given and the limits that has been given is 1/5 to 3/2. So there are 7 coordinate that we need to plot on the graph, and each of the coordinate will increase 13/70 for 7 ordinate, which is it will increase 13/70 uniformly. So the second graph is for 9 ordinate, and the limit is still 1/5 to 3/2. So we will start our coordinate from 1/5. It will increase by 13/90 uniformly until it reach 3/2. So the graph has been given have a many of area. It consists of many points that we have been calculated by add 13/90 from the previous coordinate.
Alright, that's all from us. Thank you everyone for your contribution in completing this assignment. It wouldn't have been possible without your support and teamwork. And not forget to our lecturer, Dr. Suzila, for giving us guidance to complete this assignment too. Goodbye everyone.